Hi everyone, this is Professor West and we're going to do that last example of 6.1. So our example is prove the identity below. We have 1 plus tangent squared of x over tangent of x equals cosine of x over sine of x minus sine to the third x. So for this one, it looks like both sides are what I would say are quote-unquote ugly. So you want to kind of do both sides and meet in the middle. So you're probably wondering, what does that mean? I said that earlier in class. Well, it means we're going to label one of these sides as the left-hand side and the other side as the right-hand side. All right, so we're going to do both problems for our scratch work. So I'm going to start with the left-hand side for our scratch work. I'm just going to rewrite our problem here, and we're just going to kind of go until we can't go anymore. So on my left-hand side, I have 1 plus tangent squared of x all over tangent of x. Okay? So again, we're just going to try to simplify this as much as we can. So in my numerator, I have 1 plus tangent squared of x. Well, that's the same as one of our Pythagorean identities. 1 plus the tangent squared of x is just secant of x, or secant squared of x, I mean. So I have secant squared of x over tangent of x. Okay, so I just have secant squared of x over tangent of x. Now, I'm going to change everything into sines and cosines to help us out here. So, secant is 1 over cosine. So I have 1 over cosine squared of x. And tangent is sine over cosine. So I have sine of x over cosine of x. Okay? So let's rewrite this so it's a little bit easier to do our cancellations. We have 1 over cosine squared of x times cosine of x over sine of x. And now we can see that we can cancel, and we can mark this up. This is just our scratch work. I can cancel one of these cosines with the squared of the cosine. So I'm now left with just 1 over cosine of x sine of x. And if you look at that, you realize I can't really go any further, right? Cannot go really any further. Cannot go further. So once we get to the point where it's basically all simplified, there's nothing else to do, we then switch to the right-hand side. So why don't we do our scratch work then for the right-hand side? Right-hand side. So I'm just going to go down here and rewrite what our right-hand side is. Our right-hand side was cosine of x over sine of x minus sine to the third x. Sine to the third x. Let me bring that cosine over here a little bit more. Oop, forgot the c. There we go. Okay. The first thing I see when I look at this is that my denominator right here, it looks like I can factor out a sine. So why don't we try doing that? So let's factor out a sine in our denominator. So that means I'm going to get sine of x times, factor sine out of sine as just 1. And then if I factor a sine out of sine to the third, that's sine squared, so minus sine squared of x. And then the numerator, we just keep our cosine of x. All right, so you might look here and think, hey, that kind of reminds me of sine squared of x plus cosine squared of x equals 1. And you'd be right. So remember, if I subtract a sine squared over, that means that I'm going to get cosine squared of x equals 1 minus sine squared of x. So I can replace that whole bracketed part right here. I can replace all of that with cosine squared of x. So why don't we do that? Why don't we do that? So that means I'm going to get cosine of x over sine of x times cosine squared of x. So all I did was just replace this with this because of this over here. Now it looks like I can do some cancellations. I can cancel this cosine of x with this squared. So then I'm left with 1 over sine of x cosine of x. And that's as far as we can go. However, something to note is that this here is the exact same as this here. And that is our goal. You want these to be the same. You want what you end up with to be the same. So basically what we're going to do in our proof, so for the proof, oops, let me get over to my pen here. So for the proof, we're going to want to go left-hand side equals blah, 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 equals what they meet to, what they equal here. So I would say the same thing, you know, the same part that they have, right? They both have this as their same part. So we're going to want to go left-hand side equals, follow through. So left-hand side, follow through to the thing that they equal. Same part, blah, 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 to the right-hand side. So basically, I'm just going to start my left-hand side, go all the way down, pick back up at my right-hand side, and go back up. So without the crossing out. So let's actually write the proof now that we have everything set up. And I'm going to be going back and forth to kind of explain what I'm doing here. But let's just start on our proof. So proof. We start with our left-hand side. So we start with what we labeled as the left-hand side, what we have right here. So I'm going to start with 1 plus tangent squared of x over tangent of x. So I'm going to start with, and I know it looks kind of funny when I read it this way, but think that just helps when we have line paper to do it this way. So 1 plus tangent squared of x all over tangent of x. Okay, so then I'm just going to, like we've done with proofs before, I'm just going to follow my left-hand side all the way down. Let me do this in red so you can see what I'm saying. Follow this left-hand side all the way down until I get to my final part. So I'm just going to copy that whole left-hand side of the proof we did, but in a neat fashion for the proof. So I'm just going to say, okay, this then equals secant squared x over tangent of x. All right, and again, we're just neatly copying. That's all we're doing. And then we're just going to copy again. So remember secant squared, that was 1 over cosine squared of x all over tangent was sine over cosine. So sine of x over cosine of x. Okay, again, we then rewrote it to make it a little bit easier to read. So we'll do the same here. So this is the same as 1 over cosine squared of x times cosine of x over sine of x. Okay, now this is where we had crossed off on our scratch work, but remember we do not use any notes we made or anything that we scratched off on our scratch work. We just kind of write it in a super neat fashion here on our proof. So that means that this ends up equaling 1 over cosine of x sine of x. Okay, so I finally got to our goal. So I just did the entire left-hand side. So now this is where we hop over to the right-hand side. So remember, this and this are the same. So I can basically just go, all right, I'm going to go through my entire left-hand side of the proof, which is what we just did. And then I'm going to go from star to star. And then I'm just going to go all the way back up to my right-hand side. So now I'm going to start here, which is where we are currently in the proof. I'm just going to start here, and I'm going to go work my way backwards, okay? I'm just going to write everything I wrote, but I'm going to write it backwards, okay? Let me get rid of all of that. Okay. So if you wanted to, since I had written it with cosine first here and sine first here, it might make it easier in your mind to rewrite it first to say 1 over sine of x cosine of x, and I think I will do that. That's not a necessary step, but sometimes it's a little bit helpful to think about these things that way. So I think I will rewrite this. I will rewrite this as 1 over sine of x cosine of x, just so I'm keeping up with what the proof said. Okay, and then I'm going to scroll up to show you. I'm just going to write this next step. I'm just going to write it. So I'm going to write cosine of x over sine of x cosine squared of x. Remember, we do not deal with anything that we crossed out. So since we crossed those things out, we're just going to write them. So I'm just going to say, okay, this is the same as cosine of x over sine of x cosine squared of x. All right, we're just rewriting what we wrote on the right-hand side, but backwards. That's all we're doing. Okay, and then if you recalled, we did this thing where we turned 1 minus sine squared of x into cosine squared of x, so we're just going to work backwards. We're just going to work backwards here. And I'm just going to say, okay, this is the same as cosine of x over sine of x times 1 minus sine squared of x. And then in our right-hand side, we had factored this, right? So we're going to just distribute through. So we're going to say, okay, and then this equals cosine of x over sine of x minus sine to the third of x. And notice that that is our goal. That is the right-hand side, correct? So let's scroll back up. Notice all I did was just do this proof, part of the proof backwards, and we're back at our goal. So that means that's the end of our sentence. So I put a little period here. And then we can do our little consequently, therefore, thus situation. So I can say, okay, thus, and then just rewrite what the proof said. So I'm going to do that on a new line. Again, you don't have to do it on a new line. I just think when it's fractions, it's a little bit easier to do it on a new line. So I'm going to say, thus, 1 plus tangent squared of x over tangent of x equals cosine of x over sine of x minus sine to the third x. And then I'm just going to add my little as desired. You don't have to do that, but I think it just makes the proof look nice. So I'll write as desired, since that was what we desired. And then you put your little tombstone to show that's the end of the proof. Okay, so I'm going to zoom out so you can see the whole proof here. So as you can see, I'm going to mark this up a little bit just so you can kind of understand what we did. Here, from here to about here, this was the left-hand side of our scratch work, right? It's the left-hand side going forward. And then from here to here is the right-hand side of our proof, but going backwards. So going backward. So basically, when you have two ugly sides, you know, quote unquote ugly sides, what you're going to do is you're going to do both of them. You're going to do one, you're going to go as far as you can forward. Okay, you're just going to go as far as you can. And then you're going to take the right-hand side, go as far as you can. And if you do it right, that middle part that I have here highlighted in yellow, right? That middle part, they should be the same if you did it correct. So that middle part will be the same. And then you can easily do left-hand side going forward, right-hand side going backward, and then that's your full proof. So I'm going to erase this because that's not part of the proof, but yeah. So that is how you do an example where both sides are complicated. I hope you have a wonderful weekend, and I will see you on Monday. Bye.